So d theta by theta is equal to minus u dA into 1 by ch plus 1 by cc. So we have now going into a generalized form from a small differential area. So as you saw, we need to eliminate somehow this dA. So how do we do it? Let us try to integrate. So integrate between inlet and outlet conditions. Integrating between inlet and outlet conditions. So how do we do it? Now we have only applied for a small area. We need to do it for the elemental area. So integrating d theta by theta, that is from 1 to 2, is equal to minus u times. So I will now remove all the constants here. So let us try to take it out. Minus of 1 by ch plus 1 by cc and integral from 0 to a. Okay, 0 to a u times dA. So what is that we are going to end up with? So we are going to end up with ln of, can you tell, theta 2 divided by theta 1, which is equal to minus ua times 1 by ch plus 1 by cc. Okay. So now we know what is the heat transfer between total heat transfer rate between two fluids. So now I'll take into the next page. Now we got this expression. Now we need to somehow substitute for this. So how do we do it? So we know that, you should know that before writing it. So we know that, what is it? We know that Q is equal to CH, which includes, this is a capital C, so m dot h into CH times, you can see here, TH1 minus TH2. So this is the temperature that is being, the change in the hot fluid temperature that is happening. Yes or no? Which is nothing but equal, that is heat lost by the hot fluid, correct? So Q is equal to CH into TH1 minus TH2, which is nothing but equal to CC, again this is a capital C, times TC2 minus TC1, correct apa? Here I am writing 2 to 1 again from left hand side to right hand side. So I have considered. So what is that? Now if you try to do it, or I am just writing in a different form, 1 by CH is equal to what? 1 by CH is equal to what? 1 by CH is equal to TH1 minus TH2 divided by Q. Similarly, 1 by Cc is equal to Tc2 minus Tc1 divided by Q. Now, upon substituting, let us call this as equation 6, this previous one. I forgot to give the name. So this will be 7, this will be 8. So upon substituting equations 7 and 8 in 6, we get, so that means basically we are substituting for 1 by CH and 1 by CC. Let me just show you here, 1 by CH and 1 by CC. If we try to substitute this, so what is that we are going to get? We are going to end up with this equation. Ln of theta 2 divided by theta 1 So I'm just keeping this equation here for your reference. Ln of theta 2 divided by theta 1 is equal to minus UA times. So what is 1 by CH? 1 by CH here, 1 by CH is TH1 minus TH2 divided by Q plus TC2 minus TC1 divided by Q. Correct? So ln of theta 2 divided by theta 1, which is equal to minus UA by Q times. Now shall we try to club the inlet and outlets and outlet and inlet properly? Shall we try to club it? Now I'll try to write it in a simplified form. Just see here, I'm going to write it like this: TH2 minus TC2 minus of TH1 minus TC1. So I'm just writing in a simplified form. So just see here, if I try to group it all inlets, so it will be TH1 minus TC1 and TC2 minus TC2. So this minus, if I take it inside, so if I take this minus inside, what is going to happen? So minus TH1, so minus, I've taken it here. So if you just try to do the simplification part, so which is nothing but ln of theta 2 divided by theta 1 is equal to UA by Q into, so what is this TH2 minus TC2? I'll just take you to the first sheet, that is, I'll take you back to the graph. So TH1 minus TC1, that is nothing but what? Temperature difference at the inlet of the heat exchanger, which is denoted as theta 1. Similarly, TH2 minus TC2, which is the temperature difference at the outlet, which is denoted as theta 2. Okay, now in the same lines, if we try to bring it here, TH2 minus TC2 can be written as theta 2 minus TH1 minus TC1 can be written as theta 1. Okay, so here almost we are, now we'll try to write the expression for Q. So our Q will be what? UA into, so take this denominator, theta 2 minus theta 1 divided by ln of theta 2 divided by theta 1. Able to understand? So this is what the expression for Q is, in that which is denoted as UA theta m. So this theta m is nothing but logarithmic mean temperature difference. So whenever we are trying to calculate the heat transfer rate for a parallel flow heat exchanger, some difference of temperature cannot be taken randomly. It has to be logarithmic mean temperature difference, and that is defined as what? So this theta m can be defined as what? It is theta 2 minus theta 1 divided by ln of theta 2 divided by theta 1, or which is also defined like this also. You can do it in either the way. Just that I have taken it from left to right, you can do it from right to left. So both the definitions holds the same. This is for what? This is for parallel flow heat exchanger. So this remains the same for counterflow heat exchanger also. The only definition is the theta 2 definition and theta 1 definition will be different. So theta 1 means what? Here we just saw that it is TH1 minus TC1, but that will be different in case of counterflow heat exchanger. That we are going to see it in the next video. Okay, I hope you have understood. So this theta m is what is called as logarithmic mean temperature difference. Please don't forget this. This is very important as far as LMTD for parallel flow is considered. So this is some sort of mean temperature difference that we need in order to calculate the rate of heat flow that is happening in a given heat exchanger. Okay, thank you.